Hey everyone, I've got to share with you what I got up to over the holiday break. Last episode, you saw me using a touch plate to find the 0 point on my stock. For finding Z, it's perfect. For finding anything else, like the corner of your stock or the center of a hole, it's kind of clunky and
so not cool.
So in this episode, I'm adding an affordable 3D probe as well as making a CNCJS widget to enable advanced probing sequences. We're going to go over how I set everything up and how you can add this to your own machine. Let's go. So this is a 3D probe. I found mine on AliExpress for about 60 bucks, but they're also on sites like Amazon. It connects easily via a 3-wire USB-C cable, and it can be wired up like the diagram shown here. Connecting the probe is easy, but once that's done, how do you use it? I'm using CNCJS for controlling my CNC and sending it G-code. It's free, it's compatible with Gerbil, or is it Gerbil? I don't know. That's just what I picture every time I say it. Anyway, right out of the box, there's no direct way to use this probe. What we need are something called macros, or pre-written G-code sequences that you can add and then run as needed. So first, we've got to talk about deflection. I've never really seen anyone else talk about this, so we're just going to go over that real quick. If you're not familiar, instead of simply triggering on contact, the probe works by detecting when the tip of the stylus has moved in any direction. This means that there's a bit of deflection or movement that can happen before the probe is triggered. So, first, the probe's deflection needs to be calculated. The seller for my probe included some instructions on how to do this in the listing, and you can see their explanation here. So first, we probe one side of the stock. I used a 1, 2, 3 block because I know the dimensions and it's nice and rigid. We set 0, then travel to the second side and probe in the opposite direction. Once we apply the formula, we can find the proper deflection and know how far to offset the 0 when we probe. Once that's calibrated, we're ready to probe accurately. I made a few more CNCJS macros for corner probing, for center finding, and they work like a charm. By the way, I'll link to all of those macros mentioned here in the description on my GitHub. For some folks, that might be enough. And originally, this is where I was going to end the video. But I kind of hate CNCJS macros. It's tedious, scrolling through a long list and having to pick the right file. To do the most basic operations, it feels like a chore. Also, I still wasn't able to accomplish the task that had prompted me to buy the 3D probe in the first place. Auto leveling. Why? Because no surface is perfectly flat. I made this table out of regular 2x4s and 4x4s, and as you know, wood moves. It can warp and shift with temperature and humidity, and these small dips and humps in the work surface can really cause problems when you're trying to cut precisely. I looked into GitHub user CressoT's auto leveling extension for CNCJS, and I just couldn't figure it out. It just never worked for me. But the idea is sound, and I am so grateful for GitHub user CressoT for publishing this. This extension runs in the background and is triggered by a special command you can send to your machine, along with some variables to control how it will function. Then it prepares a grid to detect height variance and alters whatever G-code you have loaded, replacing your uploaded G-code file with a new one that's been adjusted to reflect those height changes. Well, I don't want to manually type commands every time, and like I said before, I don't want to hunt through a list of macros. I want to see the results of the auto leveling, and I want simple buttons to initiate the probing sequences. So I forked CressoT's extension and got to work. Using an AI tool, I created a widget that provides visual feedback and easy to understand interface for push button probing. To test this out with known values, I modeled and 3D printed a 150 millimeter square with varying changes in height. Then I probed the corner and ran the auto level process. All right, guys, so we've got everything set up, ready to go for our first actual test. And we just hit initiate and, oh, and it's going. While it probes, we get our progress notification. We can see where it is. We're doing a 5x5, and honestly, maybe I'll want to do a little bit more higher resolution, but that's for future tests. Right now, it's going, and you can see now it's starting to fill in the visualizer. We've got our little progress thing. Let's just watch. Whew, okay, so probe complete, and now we got the option. We can apply the mesh to our loaded G code here, or just cancel, and the mesh will stay saved. So I'm going to say cancel, just so I can show you what we're working with here. This is just a surfacing operation. It's the same size as our little test piece. We have the option now, though. We can take a look what our mesh looks like right here, and I can even blow this up. Let's go into full screen. You can definitely see our baked in elevation changes. High on the left side, we got our big valley here. This looks exactly like what our, what the 3D model is supposed to be. And I can go ahead and now, after the fact, I can say apply mesh, and this is apply surface map. Absolutely, let's do it. You can't see it from the top view, but what it's done is it's altered the G code. Now you can see when it's on this side, that's all these high points. And when it's on the front, look, this almost perfectly maps. Oh shit, this is incredible for me.
Dang.
I also printed these wedges, these little guys, using known angles so that I could test the skew compensation. Once I had adjusted the part, I jogged the probe over to the front edge and ran the skew procedure. If this works, the calculated skew should be the same as the angle on the wedge, and now this feels complete. And I'm excited to get into that next project without having to jump through hoops or worry that waves or imperfections in the stock or in my table are going to screw up the job. I've posted this widget / extension on GitHub so anyone can download it for free, and I'm going to post an accompanying how-to video showing in the quickest and most direct way I can how I set up my Raspberry Pi with CNCJS and this widget from start to finish, which I'll also link to in this video's end card and in the description below once that's done. Okay, can't believe we're already done with development, so now it's time for a practical test. I have a bunch of these discard spoons where something just got a little funky, I screwed up something, and we're gonna do a little carving on the round back of the spoon. And to do that, I've made a small fixture, just the negative of the spoon, 3D printed that, and there's some tabs here, also 3D printed, that are just gonna get screwed down, and they'll hold down from all four corners, and hopefully that'll keep the spoon stable enough to do a little bit of V-carving. Here on the screen, I don't know how well that's showing up.
Mission failed. We'll get them next time.
But we've got the design that I did in Illustrator. I threw that into Fusion and projected it onto a flat surface. And we will do a 100-point probe and see what that looks like first in the visualizer. And then we're going to apply that leveling mesh to this G code and get that engraved. So let's get to it.
A few moments later.
Okay, time for the moment of truth. I've got that engraving bit in the collet, got everything tightened down. I manually zeroed Z. We're keeping obviously the same X and Y. So yeah, it's time for me to set this camera up a little bit better and then hit go. All right, there's a lot of chips you can see just packed into the cut. So I'm gonna go ahead and just kind of scrape this out off camera, and I'll bring it right back and we'll take a look. I used compressed air to blow out the chips and then gave it a quick dunk in some mineral oil. And I gotta say, that turned out better than I even thought it could. That is so clean. So there we have it, V carving on a curved surface. I feel pretty confident in how the extension and widget turned out, and invite you to check it out in the link below and give me some feedback. Hopefully you find it as useful as I do. I'm Roman for Diaz Creative Studio. Thanks for watching, and I'll see you in the next one. Don't forget, keep creating. Oh yeah, and like and subscribe.